Hey Bella. Okay, so we're going to be doing a lot of dividing today. Just like yesterday we multiplied lots of polynomials. Well, today we're going to do the opposite. We'll be dividing polynomials. And we're going to talk about some, additional rules that go along with that. And I'd like to use the video today to explain one specific part of this lesson, and that refers to zero and negative exponents, because these can be a little bit tricky to understand. Now, the first rule here that you need to understand about exponents is that whenever you have an exponent of 0, right here where it says rule number 1, anything raised to the 0 power is equal to positive 1. And that's true if you have w to the 0 power, or 10 to the 0 power, or negative 2 to the 0 power. It's kind of a strange answer, but it's true. Anything raised to the 0 power is always equal to positive 1. And to demonstrate this, to help it make sense to you, I'm going to use this example right here. And I'm going to solve it a couple of different ways. Now, the first way I'm going to solve this is just by simplifying the fraction, right? Okay, so I have this fraction here, right? W to the 4th x cubed divided by w to the 4th x. And if I write this without exponents, right? This is kind of an inefficient way of solving it, but I have 4 powers of w times 3 powers of x. That's my numerator. And then in the denominator, well, here, let me write my fraction bar first. And then when I look in the denominator, we have another 4 powers of w and just 1 power of x. And I can solve this just by simplifying the fraction, just by canceling everything out. The same way that if it were like 12 over 8, you would divide out a 4, right? Well, I divide out all the common factors. Well, all of these w's are going to cancel each other out. So if you look just at the w's, ignore the x's for a moment, every single power of w is gone. So this is completely canceled out, and the only thing remaining here is a positive 1. So sort of keep that under your hat, because that relates to what we're going to talk about with zero exponents here. Now, when I look at what's remaining, right, well, this power of x cancels out with this power of x, and that just leaves us with 2 powers of x in the numerator. So our answer is simply x squared. Now, another way of looking at this problem is to use our rule for division, which means to subtract exponents. So when we divide like bases, we subtract the exponents. And when I do that, here's the answer I get. W to the 4th divided by w to the 4th. Well, if I subtract the 4's, I get w to the 0 power. And then when I subtract my exponents for x, I get x squared again, just like we did up here. So now I have w to the 0 power x squared. And then referring back to this rule where anything to the 0 power is equal to 1, this just disappears. It just becomes a positive 1. So my answer is 1x squared, or just x squared. So you can see how this is equal to 1, because just like we did up here where everything canceled out, this was equal to 1. So this is really just all you have to remember, though. If all you can remember is that the same exponents will cancel out to 1, that's really all you need to know. The answer here is x squared. Now, the other rule we're going to learn for today concerns negative exponents, and this one's a little trickier in my opinion. It says a negative exponent represents the reciprocal of a positive exponent. So, for example, 2 to the negative 3rd, it's not going to give you a negative answer, which is a common, it's what people typically assume. Well, ask yourself what 2 to the 3rd is, right? Well, 2 to the 3rd power is 8, because that's 2 times 2 times 2. So if 2 to the 3rd power is equal to 8, then 2 to the negative 3rd power is 1/8. It's simply the reciprocal of whatever 2 to the 3rd is. So it's really just flipping it around. You're just taking the inverse of whatever 2 to the 3rd is. Okay, so for 5 to the negative 2nd power, right? Ask yourself what 5 squared is, and then take the reciprocal of that. Well, that's just going to give us 1/25. And then we'll do one more here, right? Well, you can do 3 to the negative 4th by just asking yourself what 3 to the 4th power is. And then take whatever that number is and put it in the denominator. Simply take the reciprocal. Well, 3 to the 4th power is 81. So this is going to be 1 over 81. Now, these last two here, these ones actually are easier in my opinion. 1 to the negative 1st power, well, that's simply just the reciprocal of 1, which is 1. That doesn't change at all. And then x to the negative 8th power, well, there's really nothing you can do here other than get rid of the negative. So if I say simplify this without a negative exponent, all you have to do is write the reciprocal of x to the 8th, which is 1 over x to the 8th. Okay, so I have a few more examples here. I'm not going to do all of these right now. I'll save some of these for when we meet this morning. But we're going to write two answers for each of these problems. One will contain a fraction, one won't. So if I have m divided by m to the third, I could, to get to the first part, which says write an answer containing negative exponents, I could just subtract my exponents, right? This is 1 minus 3. So m to the first divided by m to the third is m to the negative second. And then the other way of writing that, okay, well, in other words, if we want to write our answer containing a fraction, in other words, that means get rid of the negative. How can I rewrite this? Look back at these examples that we just did. If I take these as pointers, what other way is there of expressing this answer? Well, that would be equal to 1 over m squared. Okay, so same thing here. We'll simplify this one. We'll start this one the same way. We'll just subtract all of our exponents. This is going to be r to the third over r to the third. Well, that just cancels out to 1. T squared divided by t to the fourth. Subtract 2 and 4 gives us t to the negative second. So that's one of our answers. And then what's the other answer? Well, it's just the reciprocal, right? T to the negative second is just the reciprocal of t to the second. So I could also say 1 over t to the second. And finally, this one's a little trickier because you have a negative up here as well. You're subtracting the exponents. So another way of setting this problem up is to say f and then put negative 7 minus 4 in the exponent. And now just simplify this little expression here, and that gives us f to the negative 11th. And then I'll give you a second to write the other way. What's the other way of saying that answer? In other words, as a fraction instead of a negative exponent. Well, that would be 1 over f to the 11th. So there you go. That's kind of a summary of all the rules containing 0 and negative exponents, and we'll look at a bunch more examples when we meet today.